kind of accessibility across a spectrum. And at O'Reilly, we think of a lot of the areas that we're talking about in terms of this spectrum. Maker Faire grew up inside O'Reilly. It's now a standalone sister company. But we've seen the emergence of the hobbyist movement, the maker movement, and are really interested in that. So you can see these areas align on a spectrum that goes from hobbyists on one end to hardcore engineers on the other, who are designing things like industrial automation systems and automotive fail-safes. In the middle is this vast area that's accessible to people with generalized technical backgrounds, not necessarily to people with a true electrical engineering degree or a manufacturing engineering background. So all of this stuff is becoming accessible in the same way that easy electronics have become accessible to hobbyists. Medium difficult electronics have become accessible to any technical person with a technical background. We've seen the same path in software, right? Programming computers has become easier. Easy programming can be done by 10-year-olds in school. Pretty difficult programming can be done by people with just a couple of years of experience as self-taught programmers. So this is all coming to hardware now, and we're about to see an explosion of innovation in the way that people develop physical products. Now, this meets something called the Internet of Things. It meets, all of this intersects with a really acute commercial demand on the part of large forward-thinking companies. About 10 years ago, actually much less than 10 years ago, the cover on the left of The Economist is from 2010, and the Harvard Business Review on the right is from 2012. So 5 to 7 years ago, people started talking about big data, and this became an imperative in the boardrooms of every country. We need to instrument, measure, analyze, and optimize everything that we're doing. And the successor movement to this is the Internet of Things. So where the big data movement said, we'll take everything that's already digital and we'll instrument and optimize it, the Internet of Things lets you extend that mindset into everything, not just the digital stuff, but the physical stuff as well. You can instrument your plant, you can instrument your fleet, you can instrument the devices that you're selling to your consumers and analyze their usage patterns, improve the ways that you maintain your deployed product base. So the Internet of Things is an extension of the big data idea that says we have to instrument and optimize everything. And it lets us take that idea away from the strictly virtual world and put it in the physical world. And I think this represents a huge opportunity for a lot of these companies. When I look at people who are working on big data stuff, who have been working very much on the front end of it for the last few years, they've recently kind of looked up from their computer screens, having instrumented and optimized everything that's already on the internet, and then glanced out the window and noticed that there's a lot left to apply this to. So that's where a lot of the excitement is coming from around the Internet of Things. So we started the Solid conference in the fall of 2013. We announced that the first one happened in 2014, in part because we noticed this interesting convergence happening from two sides. You had these categories of companies that had previously occupied very different areas, some that dealt in physical things and some that dealt in virtual things. They're starting to cross over into each other's areas. So over the last few years, we've seen a bunch of really interesting acquisitions and internal development processes among both the digital and the physical companies that have taken them across this barrier. In the case of Google, back in the fall of 2013, they bought up all of our very favorite robotics companies, everything from Boston Dynamics, which makes those terrifying running dog robots, to the Bot and Dolly, which does beautiful robotic cinematography, mounting cameras on industrial robots. Of course, last year they bought Nest, the maker of home automation equipment. They bought a drone company called Titan Aerospace, which Facebook then followed on by buying a drone company called Ascenta. Amazon.com, having bought Kiva Systems, which makes logistical robots, has also developed consumer hardware internally. So this is a company that has made its money operating in a slim sort of virtual way. They've spun up consumer products inside not only the Kindle and recently the Echo, but also things like the Fire tablet and Fire phone. They're sort of sitting up and starting to experiment with a lot of this stuff. Facebook, of course, bought Oculus. They've released a program that uses drones called Aquila to upload and download at 10 gigabytes per second through laser connections and provide internet access in places where this isn't feasible through conventional means. Microsoft has developed a lot of hardware internally. The Kinect has become a standard tool for hardware developers who want to add some interesting sort of interactivity. HoloLens, of course, we're all interested in seeing how that fits into the ecosystem over the next few months. And even PayPal, whose entire business model has been centered on the low cost of transacting on the internet rather than the physical world where this stuff is expensive and slow and difficult, has developed beacon systems that let you pay through physical connections between, or well, wireless connections in person between phones and retailers. On the other side, we've seen these companies that have expertise in dealing with physical things, manufacturing big, heavy physical things, start to get into the virtual services world. So GE invested strategically in two very different companies a couple of years ago. Quirky, which is an online marketplace for consumer products, and tried to develop a new consumer product every week by sort of crowdsourcing ideas. They've actually just announced that they're spinning down, but for GE to invest in something like that tells you a lot. Pivotal does analytics of very large data streams like the kind that you would get from jet engines in real time. Ford Motor opened up the CAN bus system in its cars to innovators, sort of gave away a tool set called OpenXC that lets anyone plug into the diagnostic port on a car and retrieve data from the car's internal network. This is something that you've long been able to do with third-party connectors, and the automakers have never encouraged it. But suddenly Ford is encouraging it and trying to get developers on board to make use of the data that's coming out of the OBD system on its cars. Even Monsanto, whose core business is developing chemicals and seed stocks, has gotten into this and a couple of years ago bought Climate Corporation, which makes incredibly precise weather forecasts down to the level of an individual field by drawing on sensors and very sophisticated models. They also bought a company called Precision Planting that takes that lets you mount planting hardware on the back of a tractor and using local conditions as measured by sensors on the planting platform, decide which of two seeds it will plant in any given place in real time. So you're driving your tractor around, you have two seed stalks on the back of your tractor, and based on hyperlocal conditions, it decides which hybrid variant to plant in the ground. So what you've started to see is that there's this like crossover happening, and this is very casual and very conceptual, but if you look out over kind of 15 or 20 years, this is the blend that's coming about. Google, with its driverless cars, you could imagine going head-to-head eventually with conventional car makers, conventional models for owning and distributing automobiles. Planet Labs, which is a startup that launches nanosatellites, they cost like $100,000 a piece, and they launch them on commercial rockets. They're about this big, and some of them run Linux. Is entering the same space, very generally speaking, as the super heavyweight aerospace companies that have long been the only companies that are capable of operating satellites. And Sight Machine is a startup that uses computer vision to improve industrial processes. A lot of this is the kind of thing that you can do with a big OSI soft installation or Wind River. But what they do is they use really inexpensive webcams. They mount them in your manufacturing line to do quality control, and then all of the magic happens in cloud software behind the camera. So they don't need expensive hardware. They're just doing it with cloud intelligence. And they're starting to enter another area that's been dominated for a long time by very large specialized companies, like Fanuc and Siemens and so on. So to go back to the new hardware movement and how it fits in with the IoT, I think of them as kind of two separate ideas that have a lot of overlap. The IoT is enabled by data and connectivity, and the idea that you're extending software intelligence into physical space. You're drawing data in from some sensor, you're processing it with intelligent software somewhere, you're sending it back and acting on the physical world in some way through a control or actuator. New hardware refers to the lower barriers for developing physical stuff, CNC machining, 3D printing, rapid supply chains for electronics. And between the two, you can see a handful of really successful examples of companies that have taken advantage of both very wisely and combined rapid prototyping with ideas about ubiquitous connectivity and cloud intelligence. So I'll kind of walk you through a handful of the big thoughts that we think about around Solid and at O'Reilly when we look at what's happening in this space. One is this idea of the God server, which is a term that I've borrowed from someone else. The idea is that in each of these kinds of content, each of these platforms, there has emerged a distributor, an intermediary, that ends up knowing more about consumers than the producers of the content do. So in the case of books, it's Amazon. In music, it's Apple through iTunes. In movies, it's Netflix. Each of these distributors has harvested a lot of really valuable data from the process of selling books, music, movies, and so on. And you've started to see them adapt their knowledge to create new experiences for people. So in the case of Netflix, the company has used its intuition about consumer preferences for watching movies to develop really outstanding original series that you can only watch on Netflix, right? Netflix knows when people pause movies, when people give up on movies, which movies people watch multiple times, which segments people seem to enjoy, and they can reflect this back into the content that they're developing. In the case of Amazon, the Kindle sends a lot of analytics back to Amazon, so they know which pages you're reading slowly, which pages you're reading fast. They know when you're likely to give up on a book. They can look at the characteristics of the natural language in books and figure out how it relates to whether you're enjoying the book. And Amazon is thought to be experimenting with actually generating books with natural language processing. You can imagine that for things like romance novels, this is actually possible. You just sort of take the same set of language and jumble it up, and genre fiction. It could be possible in the next 10 years or so. So everyone is waiting for this kind of God platform to emerge for wearables, connected devices, the smart home, and so on. And I'm not quite sure where it will come from. We're all kind of watching to see how it will emerge. A lot of organizations that have started to create environments for consumers to enjoy these kinds of devices have created platforms for it. Garmin has one that's really interesting for wearables and fitness. Nest has one for the connected home, as does Philips through Hue. Qualcomm and Intel are kind of jockeying for a more general position as kind of center points in connected devices. So this is one of the things that's a big question mark in the development of wearables and connected devices. We're really interested in this idea of hardware and Internet of Things endpoints representing APIs for the physical world. So again, this is a big part of speeding up innovation. You make the process of innovating more like the process, you make the process of innovating in hardware more like the process for innovating in software, which is very fast and very fluid. And that means that you open up APIs for physical processes. This makes it very easy to interact with physical things. It could be something as simple as being able to turn on a hue light bulb by going through an API and sending an on signal. It could be something as sophisticated as plugging into to the diagnostics of a car, combining that with data drawn from a mobile phone, and understanding something about where your friends are in a networked environment to start to see, to develop a measure of social wellness. Are you leaving your house and visiting your friends? In a lot of these applications, we see a critical component being the replacement of physical complexity with software. So you remember devices are getting faster, they're using less power, they're getting cheaper. It becomes easier to use high-level software to do things that you used to have to do through analog processes or electronic processes. So software can run very quickly on embedded systems and do stuff that you used to have to do electronically. And at an even higher level, you see software controlling physical processes that makes the entire design of the physical device easier to accomplish. So, for instance, this idea of replacing mass with math, as Astro Teller at Google has put it. Driverless cars can be simpler and lighter and involve less physical complexity if they're driven properly. So human-driven cars have to account for human error in a lot of ways. They're very heavy. They have strong brakes. They do all sorts of things to counteract the mistakes that we make. If you replace the human driver with software that never makes mistakes, suddenly the physical complexity of the car can go down. And design after the screen is something that we're following very closely. As we develop more connected devices, as more things kind of connect to each other and to the internet, we see the interaction patterns changing. We see the way that you interact with devices changing radically. And in particular, this idea of zero UI that's emerged. The Nest thermostat is a great piece of hardware. Its user interface is widely praised, but the most interesting thing about its user interface is that you don't interact with it after the introductory period when you program the Nest. Right? So you're giving up the user interface because it's intelligent. You don't need to interact with it through a screen. It just kind of interacts with you in an unintrusive way. It knows if you're home, so it reacts to that. You don't have to tell it that you're home. In the same way, if you imagine kind of a driverless car, in the current model of deciding that you want to eat sushi tonight, you would go to your phone, you would ask your phone for a sushi recommendation, you get the address, you put it into your navigation application, you read off the navigation application as you drive. So that's three different transfers between interfaces. You can imagine that a driverless car might someday be able to take your request to say, I feel like sushi tonight, and then just identify the sushi restaurant you ought to go to and drive you straight there. So we see a collapse of interfaces, fewer and fewer interfaces, and fewer interactive steps between people and their devices as this stuff becomes more intuitive and more intelligent. So I'll leave you with a thought that I really enjoy as I've worked on this conference and this publishing area, and have talked with a lot of people who are doing innovative stuff outside of what we would conventionally call technology. So if you try to sort of pin down what a tech company is, this is a term that's overused in the press. People talk about the tech industry. People talk about the tech community, the tech space. What they really mean is some vague notion of R&D driven, engineering heavy companies. If you go and you look up the definitions of any of this, it becomes much broader. And if you look in particular at the category of the official SEC industry classification that includes Google, which is something like web portals and services. So let's say Google is the archetype of a tech company. We'll look at the other categories in its category. You have things like almanac publishers online, greeting card publishers online, forums where people talk about parenting online. This stuff is pretty stale, really, by now. This isn't new. This isn't novel. I've met a furniture manufacturer that is more technologically adventurous than any of the companies that fall into this category. So what we say now is that every company is a tech company now. This area of technology, now that software can interact with the physical world through new hardware, through connected devices, makes it possible for any company to adopt the technological mindset, to look for insight in its data, to work intelligently in physical environments. And that opens up an enormous range of possibility. There's a huge greenfield to make the world safer, more efficient, more accessible, and as our founder says, to work on stuff that matters. Thanks very much.